I'm going to work through the problems on this test 1 review. This is the section where we're covering what are called conic sections, parabolas, ellipses, and hyperbolas. For the exam, you will be given these formulas. So for each conic section, there are 2 formulas: parabolas, ellipses, hyperbolas. And then here at the bottom, for ellipses and hyperbolas, they will oftentimes ask you to determine the foci. So here are the equations that can be used for that. So I will go ahead and work through these problems on your review. At the end of the review, you have a key, so you have the answers to the questions. And hopefully, I will do the problems correctly. If I happen to make a mistake, then I will go back and try and find my mistake. So I'm just like students in a sense. I may make a mistake. Hopefully I won't. If I do, and if my answer is wrong, I will go back and try and correct it. So this is real time. The way this review is structured, the first few problems will be on parabolas, then there will be problems on ellipses, and then there'll be some problems on hyperbolas. And once again, the problems on this review should look a lot like the kinds of problems that you will see on the exam. So let's go ahead and get started. Once again, I'm going to work through these problems fairly quickly. I will try and describe what I'm doing as I'm working the problems. I'm not going to go into a lot of detail explaining why I'm doing what I'm doing. I've done that already in the video lectures, but this is mainly just working through the problems. All right, so problem number 1. For the following equation of a parabola, determine the vertex, focus, and directrix, then sketch the graph. So here's the equation of the parabola. Eventually, we'll use this to sketch the graph. And they want us to find, looks like 3 things: vertex, focus, and the directrix. With all these kinds of geometry problems, the first thing you have to do is to, if you're given an equation, to make sure the equation is in standard form. So if I go to my formula sheet, here are the 2 formulas for parabolas. Standard form, the thing I really look at is whatever the squared variable is. In this case, x minus h is squared, so we call x the squared variable. For the other equation, y is the squared variable. You notice there's no coefficients, no numbers in front of the parentheses. If there is a coefficient, it's always on the other side. So here, although there's no parentheses here, we learned in class that that means that the h is going to be 0. Matter of fact, just to be very clear, since my x is squared here, I'm going to write down the standard equation from the formula sheet. And I'm even going to sort of switch the sides from the formula sheet to make it look just like the equation I was given. So for 4p y minus k, so y is not squared, so I use this equation. And the other side is x minus h squared. So the first thing I notice, first of all, it can be a little confusing. I'm expecting 2 parentheses here, but I don't have a parenthesis for my x squared. Well, like we explained in class, that means the h is 0. Just to make it very clear, x squared is the same thing as x minus 0 quantity squared. So right away, I know the h is going to be 0. But before we do that, the first thing I want to do is to make sure my equation is in standard form. You notice here, standard form means there should not be a coefficient in front of this squared parenthesis. Right now, I've got a 2. So I'm going to divide both sides by 2 to get the equation in standard form, which is going to leave me with minus 4 y minus 2 equals x squared. So now the equation is in standard form. And now by looking at the equation and comparing it to the standard equation, I can determine what P is going to equal, what K is going to be, and what H is going to be. Like I said before, the standard equation allows us to figure things out. Now, as it turns out, the vertex, which we will show you in a minute what the vertex is, the vertex is an ordered pair where H is the value of X of the vertex and K is the Y value of the vertex. Well, from the standard equation, I can look H, X minus H, in this case, like I showed you down here, H is going to be 0. K, Y minus K, here, Y minus 2. Now, the little rule I taught you in class, which always works, which I use, when I'm looking to find H and K, when I have a number here, in my mind, I think of this whole thing as minus 2. And then when I go down to put it in for K, it's always the opposite. So I go up here, I'm looking at minus 2. When I plug it in here, it becomes the opposite. So now the vertex is going to be 0, 2. I need to find 3 things, H and K and P. I found H and K. Now if I can determine P, then I have everything I need. P, I can find from looking, the coefficient front of the Y parenthesis is 4P. And over here it's minus 4. So therefore 4P is minus 4. And therefore P is -1. Now the one thing I should have mentioned, which I haven't yet, let's just do it now. Once I got this equation in standard form, and I realized that this is the equation I'm going to use, this I know is the standard equation if you have an up or down parabola, right? An up parabola or a down parabola. Now, once I get in standard form, I actually can look and determine whether I have in fact have an up or a down. And the whole key is the coefficient in front of this parenthesis. If it's a negative number, turns out it is what we call a down parabola. And once again, in class, what I suggested is I think of this as like a smile or a frown. A positive person smiles a lot. So if this coefficient, this number in front of the parentheses is positive, you have a up parabola. A negative person frowns. Since the number is negative, it's like a frown, which is like a parabola down. So for this problem, when I get ready to sketch it, it's going to be a down parabola. Now, really, since I found the vertex and the value of P, I have everything I need to start sketching this parabola. So the vertex 0, 2, x 0, y is going to be 2. Since I know this is a down parabola, I know it's going to go like this. I am next now going to graph the focus. The focus, you move a distance P from the vertex. So if this is the vertex, P, although it's -1 here, for my purposes, I really just care about the actual, what the number is. So in my mind, I'm thinking I have to move a distance of 1, and I'm going to move down, because I know the focus is going to be inside the parabola. I know it's a down parabola. And in the same way, the directrix, you move a distance C, the opposite direction from the vertex. So from the vertex, I move down 1 to get the focus. I move up 1 to get the directrix, but the directrix is actually a line, and we like to make it like a dashed line. So this dashed line is the directrix. Matter of fact, a horizontal line, the equation of a horizontal line is just going to be the value of y. So the directrix is actually going to be y equals 3. And that's one of the questions we're asked. Here's the vertex. We're also asked the focus. Well, we have the focus now. The focus is going to be 0, 1. Now, the last thing I need to do is just try and make a rough sketch of this graph. Now here, we want to calculate one other piece of information that's going to help us with our sketch. I like to call it the spread, because the spread tells me whether this is like a skinny parabola or very wide. The spread is 2 times p. And once again, although up here you see p is -1, I don't really care about the negative for this spread. I'll think of p as just 1. You'll see in a minute. If the spread is 2, what that means is I go to my focus, not the vertex, but the focus, and I'm going to move 2, this distance, since the spread is 2, move 2 to the right, and then 2 to the left. And these 2 points, along with the vertex, give me the ability to make a pretty good sketch of the graph. So I go here, and then to the other side. And that should be a pretty good estimate of what this parabola should look like. Now I'm going to check the key to see if I'm correct. Hopefully I did not make any mistakes. So the vertex is 0, 2. Focus is 0, 1. Directrix y equals 3. And my graph looks correct. All right, so that's one where they've given you the equation of a parabola. They ask for information and the sketch of the graph. Here's another one. Looks like the same kind of problem. They've given you the equation of a parabola. They ask for information and then the sketch. So once again, first thing I need to do is try and get this equation in standard form. So I noticed that in the standard form, the parentheses are always on opposite sides. And once again, I want the squared parentheses to not have any kind of coefficient. So let's first, I need to move this whole second term to the other side. I'm going to add 1/8 times this parenthesis. So I'm going to have now x minus 1 equals 1/8 y plus 2 squared. All right, so I'm just doing some pretty basic algebra. Now, once again, to have an equation in standard form, so it looks like it's going to be this equation. I know this is going to be a left or right parabola, but the key thing right now I have to be aware of is that I can't have any kind of number or coefficient in front of the squared parenthesis. Right now I've got an 1/8. So I'm going to move that to the other side. The way I'm going to do it, I'm going to multiply both sides by 8. So when I do that, I end up with 8 times x minus 1 equals y plus 2 squared. So now it's in standard form. Matter of fact, let me write down the standard equation. So it's this right here, 4p x minus h equals y minus k squared. So once again, this is a equation for a left or right parabola. And if I look at my number here, since it's positive, now with left and right, so here's a right opening parabola because it goes to the right. Here's a parabola opens to the left. How do you remember what is what? The one that opens to the right, this is like the positive x, right? If you think about the x-axis, positive x-axis is on the right. The negative x-axis is on the left. So this opens to the right where the x is positive. So therefore, if I have a positive number here, I must have a parabola that opens to the right. So just like the previous problem, if I can find h and k, I'll know the vertex. If I can find the value of p, then I've got everything I need to complete the problem. So the vertex, once again, is hk. So for h, once again, I grab this number, including the plus or minus in front of it. So I think of h as -1, and when I put it down here, it becomes the opposite. If I'm looking for k, I think of having a +2 here. I make it the opposite to go down here. So there's the vertex. I might as well go ahead and plot it. So it's 1, -2. So once again, I can now start to imagine that this is going to be a parabola that opens to the right. So there's the vertex. Let me go figure out what the value of p is going to be. Well, if you look here, for p has to equal 8, which means p is 2. So now I know the focus is inside the parabola. Since the parabola opens to the right, I'm going to move a distance 2. So here's the vertex. I'm going to move a distance 2 from the vertex to the right. So there's the focus. And then if I move a distance 2 to the left, that's going to give me my directrix. And in this case, since it's a vertical line, the equation of the directrix is going to be the value of x. X is -1. So this is the directrix. The focus is x3, y -2. Now, the last thing I need to do is make the sketch. So once again, I'm going to calculate the spread, which is 2p, which is going to be 4. So now from my focus, I'm going to move up 4 and then down 4. And then I can make my sketch. 1, 2, 3, 4. 1, 2, 3, 4. So this one is wider than the first problem we did. So once again, let me peek at the answer to make sure I didn't make any mistakes. Vertex 1, -2. Focus 3, -2. Directrix x equals -1. And then the graph looks like this. If I look at the graph on the back, although it's a bigger graph, but if I look closely, this is correct. All right, so those first two problems were problems where you were given an equation and asked to figure all that stuff out. Now the third problem, this is where they give us the graph of a parabola and they want us to find the equation. So in this case, the first thing you do, you recognize we have a downward parabola. So I'm going to go to my formula sheet and write down the standard equation for a parabola that opens down. This is where you have to know that this first equation is the up or down parabola. So this is the equation I'm going to use for this problem. So I'll write it here. Standard equation is going to be x minus h squared equals 4p y minus k. Now, when I'm all done, when I find the final equation is going to have x and y in it. So that means the remaining variables in here, h and p and k, those are the things I need to figure out what they equal. Those are going to be numbers. So I need to figure out what h equals, what p equals, and what k equals. Well, here's the way to start. I know the vertex is hk. It's going to be a point on my graph. If I can determine the vertex, if I know where the vertex is, then I can figure out h and k. Now, if you look at this graph, the vertex, sometimes these lines are hard to see. Matter of fact, sometimes this pen bleeds through. Oh, doesn't help. Hopefully you can see that the parabolas here, this focus looks like x is 3. I believe in looking at this, we know the vertex is right here. I'm pretty sure it's going to be 3, 3. So that means h is 3 and k is 3. So in a minute, I'm going to plug in 3 for h and 3 for k. Let's go ahead and determine what p, we can figure out what p is equal to, and then we're pretty much done. Well, p is the distance between the focus and the vertex. So from here to here is the distance of 3. That means p is 3. So now I can plug p and h and k in here. So x minus h is 3. If p is 3, 4 times 3 is 12. And then y minus k, and k is 3. Here's one thing even I sometimes forget. When I'm pretty much done with the equation, I need to go back and check and make sure that this number is correct in terms of positive and negative. As a matter of fact, since this parabola opens down, I know that this number has to be negative. So at the very end, I have to remember I need to stick a negative in front of the 12. Because this parabola opens down, and a parabola opens down has to have a negative number. So sometimes you figure out your equation, and it feels like you're done where you're not quite done yet. You need to check the sign of this coefficient. So let me check and see. Hopefully that's correct. X minus 3 squared. Let me see. As a matter of fact, I think I can just erase these problems. I can maybe tear off the key. I'll have to keep flipping back and forth. So here's the problem we worked out. Here's the key. Number 3, x minus 3 squared equals negative 12 y minus 3. So it looks like this is correct. Now the next problem is find the equation of the parabola with the focus at 5, 0 and the directrix at x equals negative 5. So this is a problem where they give you what I call information about the parabola, and they're actually trying to find the equation. Now the way you have to do this, I mean, some of you might try and do it in your head, but I highly, strongly discourage it because you're just going to make mistakes. Whatever information they've given you, sort of go off to the side and try and make a graph based upon what you've been given. And then once you can see it, normally you can figure things out pretty easily. So let me go over here. So the focus is at 5, 0. So right there is like the focus. And the directrix is at x equals negative 5. There's a directrix. Now, from looking at this, I know since the focus is always inside the parabola, here's the direction. I know right now this is going to be a parabola that opens to the right. And from the formula sheet, parabola opens to the right is going to have this standard equation. So let me write that down. Y minus k squared equals 4p x minus h. So once again, if you're ever trying to determine the equation of a parabola, if I can figure out the vertex and the value of p, then I'm pretty much done, right? Because the vertex gives you h and k, and then you have to find p. Well, from this little sketch of my graph here, I can find the vertex because you know what? The vertex is always halfway between the focus and the directrix. So if the focus is at 5, 0, and the directrix is at x equals -5, halfway in between them is right here at 0, 0 at the origin. Turns out the vertex is 0, 0. What that means is basically I'm going to have y squared equals, once I find p, plug in p, 4 times p times x. In other words, the h and the k are 0. The parentheses go away. Now I need to just figure out what p is. Well, p is the distance. So now really, I know the vertex is right here. P is the distance from the vertex to the focus or the vertex to the directrix, either way. But I can see it's 5. So 5 times 4, I'll write it here. So P is 5. 5 times 4 is 20. So it looks like the equation of this parabola should be y squared equals 20x. And if I look at my key number 4, y squared equals 20x. All right, not too bad. Now you can see number 5 is sort of crossed out. I created this review a few years ago, and at that point in time, we were doing an extra kind of problem, which we're not doing nowadays. So we're going to skip 5. And now we are ready for ellipses. What I would do, I'm going to go ahead and stop, and I'm going to start a new video on ellipses. So this first video will be the review problems for parabolas, and the next video will be for ellipses. So let me stop now, and then we'll start with a new video.